Hello, everyone. So we are a couple of minutes before the official start, and that means it's the perfect time for me to show our intro screen. For those of you who are joining our automation case study for the first time, this is the fifth part. In the previous couple of months, we've taken a good look at how some basic tooling works, and we've understood the problems in this space. For this particular moment, we're bringing it all together in a description of a virtual supply chain. Now, the reason we're doing this is very practical. We have a situation where in the global supply chain, some companies are incredibly sophisticated and highly automated, and some companies are the opposite. They do not have much automation at all. We want to try to encourage companies to explore automation as a way to do compliance scanning more quickly and more effectively. We want to overcome perceptions that are there about barriers, for instance, barriers due to cost or complexity. Our case study has been centered around using a certain type of graphical user interface created by TNG in Germany and supported by Facebook, which allows a company to call quite a few different open source and therefore free to use, free to modify, open source license scanning tools. This is a big deal because a lot of companies don't have resources to put into this space, and having a simple graphical interface to call whatever tool suits them is a big step forward. But rather than simply highlighting the tools, we want to go one step further. It's all very well to introduce automation which can help internally. But if we're addressing the whole supply chain, we want to think about automation as part of that, something that makes the supply chain work more effectively. And that leads us to software bill of materials, which essentially is a way to describe the software that you've scanned in a manner that you internally and other parties externally can understand. Everyone can understand quickly what software it is, what version it is, what license it's under, and other information. Now, there are a few different software bill of materials out there. We are focusing on SPDX, which was recently granted ISO status as ISO IEC 5962. SPDX is a mature software bill of materials. It's been about 10 years as a de facto standard. The ISO grant was this year, so it's just been perfectly positioned for long-term integration in use, not only in areas like consumer electronics, but also in automotive, aviation, defense, and so on and so forth. So there's a graphical user interface to call various tools easily. There are various tools out there under open source licenses that allow you to do open source scanning really cheaply, if you so wish. And by combining the graphical user interface and these open source tools, you can reduce the barrier to entry of automation dramatically. The question is, when there's a supply chain of different companies using different tools, can SPDX solve the problem of communication? Can we have multiple companies using SPDX in different tools and send good software information from the beginning to the end of the supply chain? And that's what Max will cover today. Now, before Max gets started, here's the antitrust policy notice that we show at the beginning of every meeting. The full antitrust policy is on the Linux Foundation website. And if you're from one of our member companies, feel free to contact our counsel, Andy Updegrove, with any questions. And onward we go. A virtual supply chain, open source tooling for open source automation using the SPDX software bill of materials standard. Max has been hard at work to create a demonstration of this, which will give us an idea of the state of the market and an idea of where things need to go next. Max, over to you.
That was an impressive introduction. I hope I can somehow accomplish what you promised. Let me take screen sharing.
Max, can you hear me?
I can hear you. Can't you hear me?
That's strange. I can't hear Max.
Can you hear me now?
Yes.
I can hear Max finally.
Sorry, that was.
Yeah, we can hear you both.
Okay, perfect. Let me just do one very last adoption that I missed to do to my screen resolution, just to have. I just want to share full HD instead of more, just to keep the performance up. And
that sounds good. And just noting, we have people literally from all over the world on this call. So we have a nice international group. And of course, we're recording this, so there'll be a very long tail in viewership over time. A huge amount of people are interested in this topic.
And I'm prepared. So my plan here today is to build an example that we can use to demonstrate how to share and how to build a bill of material over multiple parties that are collaborating on building something. And I just chose something with a more sloppy style of writing that gives me some space to make errors. So the goal is to show this virtual supply chain. Where's my next slide? I need to find it. My next slide is there. My example I will look at is a tutorial example that demonstrates how to build WebAssembly from Rust, and I will show how to deploy that. So that's the book corresponding to this example, and all the source code is on GitHub. I will share the links later so that you can also try it yourself. The interesting thing with this random example that I picked is it's for one Hello World example that is licensed correctly and that can be reused. The second thing is it contains several steps. It contains Rust source code that gets compiled to WebAssembly, that then gets combined with Node.js code and then can be deployed somewhere else. So that's a simple example that that is a multi-step process that will help to demonstrate the virtual supply chain. And the final product will actually look like that. It's a game of life simulation that runs in the browser. That, just as a fun fact, that is what we are packaging and building. So back to the slides. And let me just copy that. I failed to copy. Sorry for the chaos. Why did I fail to copy that? I need to go back to my slides. I just killed my slides. That's annoying, but that's not a problem. I failed to copy the link. I will share it later. Okay. My next plan would be to just graphically explain how this build of this example project works. This example project, as said, is Rust code that gets compiled with some custom WebAssembly packaging compiler, and then gets packaged with Node.js code, so that we, in the end, have some complete server, and we continue by adding that complete server to a Docker image that is based on the OSADL Debian image, just to have some clear license information on that side. And so to deploy this web server on the Debian image, we need to install Node.js on the Debian image and install all the dependencies after that. So all the code is actually here. You need to to build that, and you need to combine that and the necessary Docker commands are on that side. It's if you want to follow around or try it afterwards. But so that's just the build as you would do it in one organization. The goal is to demonstrate how that works over multiple organizations and later how the compliance documents can flow between these organizations. So to do that, I just add arbitrary boundaries between these organizations or between these steps. I say the first step that is done, is the compilation of the Rust code, and that combines that with dependencies is done by organization number 1. Then organization number 2 packages that with the Node.js code, and the OSADL organization provides the Debian image. Some organization 3 enriches that Debian image with Node.js and provides that to us. And organization 4 combines the result from all the previous organizations and builds a complete Docker image. So that's all the steps I want to see. So to have to repeat that, I've written down what I just said here. The organization 1 compiles the code, and I can draw that clear. The organization 1 compiles the code into this WebAssembly package. Organization 2 here bundles that with some Node.js code. OSADL provides the Debian image. Organization 3 installs Node.js on that Debian image. And organization 4 combines these 2 dependencies into a final Debian image, into a final image that contains the WebAssembly server, and that is running here still. Is the font size big enough? Can that be, is that possible to read that? Is that fine?
I can read it.
Okay. Good. So based on that example, we can now think about where does open source come into that picture. So there are several places where open source is pulled into that pipeline. The first one is organization 1 is building the Rust code that includes dependencies that get used and put into the output. And thus gets redistributed in the end. The OSADL provides their Docker base image itself as open source. The organization 2 installs Node.js, obviously. That's open source that gets pulled into the dependency, into that chain. And organization 4 runs npm install, and that, as we all know, pulls lots and lots of open source. Maybe I need to make that arrow a little bit thicker to represent that. So there's also source code pulled into that chain. So that's the base setup I want to talk about. That's the build I want to enrich with compliance information. So are there already questions related to that? Otherwise, I would go on and talk about how to add compliance information here. Since that is the basis, I will continue on. I just want to that it is clear and that there are no open questions. Okay.
Looks like we're good.
I will continue. Great. Yeah. So, how to pass compliance information on in this tool chain or in this supply chain? The first thing that I want to highlight is The OSADL Debian image is special since it comes pre-cleared and it comes with sources within the Debian image itself. So it's a self-contained compliant distribution. And for the other places, we will add tools that run. So I've demonstrated that. I've written that here. So the OSADL image already contains the sources and contains the compliance information there. For the Rust source code and for the final JavaScript WebAssembly result, we can use the OSS Review toolkit. That's done out of convenience here that both tools that both are the same tools, since they generate SPDX that is compliant and will be many tools generate SPDX that is compliant. The word I was looking for is they generate SPDX that is compatible. That is the same version of SPDX that is the same format, and I will show in the next step why this is important. And for the Node.js image that is based on the Debian OSADL image, we use turn to extract the information what was added via this install Node.js step. So turn extracts at this stage into an SPDX file what additional dependencies came into the loop there. So this is how at every step we can extract the open source the information what open source was added. The minor confusing thing is that open source is added here in organization 4, but organization 2 already computes what dependencies will be pulled by npm install. That's the only mismatch here, but that with material can be passed on then. So that's how the how the tools can be added to this toolchain. And after that, we want to combine the results. So that's the actually already last step, how to complete this toolchain. And here just to demonstrate 2 ways of how that could be done. The first way is since this bundle here, this WebAssembly with server bundle consists of both the Node.js code and the WebAssembly binary. In this example, we will generate the SPDX file for that by placing the SPDX file from that describes the WebAssembly binary into the project that finally generates the last the SPDX file for organization 2. So that means that this SPDX file here at this point that will be distributed by organization 2 already includes all the information that was provided by organization 1. We will see that immediately, very soon. And the second way of how to combine multiple SPDX files is demonstrated in the distribution of organization 4. In this example, organization 4 will distribute multiple SPDX files. So it will just redistribute these 2 SPDX files provided by 2 and 3 and generate an additional SPDX file that links them together via external document refs. So it's reusing previous SPDX files by generating a new SPDX file that describes the relation that the new distributed thing is now a bundle of these. So that is the state of the tool chain or of the supply chain and how the compliance information is passed through. Now, since I explained how this example looks like, this example is also on GitHub and on encoded in code. So there's a folder for every organization in the GitHub project. And if I look into the first organizations folder, it basically consists of 3 parts. There's the source code that organization 1 owns and that gets compiled. There's a script that does the compilation, and there's an output an output SPDX file that that describes the result. So if I go back to that slide here, so that is on GitHub is this source code, is the final output file, and the rule that how this is all combined. And I could even build the result, and that is now building. I don't need to watch that, but in the end there will be an output file. So also the building is working in the distribution. And additionally, there are some other reports added just for convenience. They are not represented in the supply chain. They are generated and put into this repository to have an additional view on what is online or what is passed through. For example, it's convenient to have the scan web app of that is generated by the OSS Review Toolkit, so I can look into the dependency tree with that what the OSS Review Toolkit generated. So that's the dependency tree that is generated by the first build here at that point. There are also additional reports that explain them, and there are also the files to look into them with the Opossum tool. So that is provided here in a very simple way. It's since the goal is to demonstrate how the SPDX files are flowing through the system. And the same is true for organization 2. Organization 2 consists of source code, a script, and a bill of material that describes the result from the build. And if we look into that, let me this time open it with Opossum. We can see the input consisted of 2 parts. As we have seen here, the input consists of the Node.js code and the WebAssembly code that is represented here by the dev folder for the Node.js code that also contains a package.json, and the package folder, that's the redistributed WebAssembly code. And as we can see here, the redistributed WebAssembly code contains the project.spdx.yaml file that describes the dependencies that are contained in this WebAssembly file, or that are used to generate this WebAssembly file. And in this the .dub folder, we see the dependencies that are brought into the build by npm. So there's a way of combining these 2 inputs into a new SPDX file, and that SPDX file is here. I think I have not yet shown an actually SPDX file, but as expected, it's a long YAML file that describes that we have the ANSI color dependency and all the metadata for these dependencies. So as described by Shane, this that's the content of the bill of material. And just as a last thing in the terminal here, there's also the output from turn. So that's the file here. That's the report that describes what was added to the OSADL base image. And if we show into that report, we can also see that base pass WD was installed, or BSD utils, and so that's also a bit of material that helps us to understand that. So that are these two files, and they are generated as explained. And the last piece here, how the supply chain is links these two together, is actually also in Git, but I also put it here. The to link two documents together, one can write something like this document here that contains external references. So it points to external documents and uses these documents and describes relationships that the thing described here contains the content of these two documents. So that allows to build a bundle of someone started screen sharing. Let me just.
It's a troll. Let's see if we can get rid of this person.
I'm screen sharing again. So that's how the final bundle can be described and can be distributed as multiple files. And that approach also extends to you can describe arbitrary relations between these documents, and you can describe multiple files. So that's the example here. And just to mention it, there are a lot more tools than that. I think this, there's this Google Doc in which the tooling ecosystem with SPDX is described and tracked, and it's mentions a lot of tools that are able to consume or to produce or to manipulate SPDX. So you could. Is my screen sharing still active? I just got. I'm not sure if the troll is back again. So this describes.
Yeah, you're working fine.
Okay.
Yeah, good.
So here you can see which tools can be connected via SPDX. And so instead of OSS Review Toolkit or instead of Turn, one could have used Fossology plus SW360. SW360 itself also has the functionality to describe relations between components and describe projects and to combine SPDX files. Scancode could have been used. There's this random Haskell library that could have been used, and SPDX tools also were not mentioned on this in this description. And there are more and more and more tools that are in the SPDX ecosystem as mentioned here. And that is the overview of how the compliance information can be passed through with SPDX, how it supports merging, how it can be reused, and demonstrates some different examples of code on GitHub. I think there are probably a lot of questions and a lot of confusion in the room. Other questions? Can I
have a question to start, if that's okay. So
Sure.
this obviously involved a lot of exploring SPDX support and the tooling. From a big picture, how are we doing with the support of SPDX in the open source automation tools?
I think there are many tools that support some flavor of SPDX. It would be better to have some convenience features like a tool that consumes arbitrary SPDX and outputs SPDX 2.2 JSON or SPDX 2.2 YAML. Something like that would have made the experience a lot easier. So I think there are on the convenience tooling side, there's some space left. Also, there are minor differences between how tools use SPDX that still need to be resolved and that still cause some headache. So, for example, there's a new issue in ORD that describes just a minor thing, but there are still some things that could be simplified. But all in all, it's on a good way, and it's the consumption and combination side is harder. The generation side is already very far. It's combining the outputs and redistributing and manipulating them where I still see a lot of possibilities, although there might already be several tools that fill these gaps that I might not be aware or that I haven't presented here. So, for example, SW360 that allows to import several SPDX files, modify them, and export a combined SPDX file for a project. Any other questions?
I just noticed Stephen had a comment in the chat.
Okay.
Just that it seems that quite a few tools can export SPDX, but fewer can read it and import it from other tools.
Yeah. There's there's not that many tools can consume and can combine SPDX, but that's one of the disadvantages of such a impressively capable format. So SPDX can represent very complex information in very complex ways, but that also makes consumption complex and generation easy.
That makes sense. That makes a lot of sense. I've got a secondary question to this, which is, I know our focus here is on open source tooling. Did you get any impression of how things are going on the proprietary tool sense as well? So if in the middle of our supply chain, someone has a proprietary tool, does it look like they're also aligning behind SPDX support that we need?
I'm not an expert on that. I think if they would export something that is passable SPDX, it could easily be added into this picture and into the supply chain. But I don't. Maybe someone else has a comment on that.
Of course, thank you. Oh, Sebastian has a question. Sebastian, over to you.
Thank you very much. Yeah, I wanted to ask, when you demonstrated Opossum UI and Ort's web output, there was information under package.json, a list of the dependencies. And I was wanting to know if that was included in the bill of materials itself, or whether it was fetched automatically from the internet based on the references that the bill of materials had.
So, for example, the information that how the dependencies relate here, and
yes, exactly.
I think most of the generated bill of materials SPDX files are SPDX Lite files that just describe the dependency tree, and I'm not perfectly sure, but we could check. We could just look into the if I can type, we can just look into the SPDX file, and in the end it describes relations. It's just a big file, and I seem to have a slow PC, so I'm waiting to scroll down to the end. Yeah, so here you see the relations between the packages. So there's the there are the dependency relations. So here's, for example, the statement that the root package depends on SYN, and the question would now be if there is a dependency tree or if every dependency depends on the root package.
Yeah, and I see that package down there has its dependencies of its own listed. So so you have package 31 sin as an example, and then there are multiple dependencies of that if I read the relationships correctly.
In which line are you, so that we can follow?
Okay, so in line 11 1104 we see package 31 sin, and then hat has a relationship from source artifact.
That's a generated from relation. That does not describe the
I see, of course.
That describes I know what the sources for that artifacts are, and they are I can let me just I will just convert that SPDX file to a possum, then I can have a look at the dependency tree. That takes just a second, and then I can answer the questions. Are there other questions in the meantime?
I saw we have a comment from Mattia that he has some experience with proprietary tools, and they are often willing to provide an export of SPDX, but hesitant to import it. Interesting observation.
Yeah, and as far as I can see, the SPDX file contains a root package. Every the root package contains all the transitive dependencies as direct dependencies in the SPDX file, or at least for the odd output here. And then every dependency contains its source dependency as dependency here. So I can see, yeah, that's the content of the package in the SPDX file.
Thank you, very interesting. So it looks as if a possum is capable of using external refs to fetch in additional data after you create.
It's not fetching additional data. It's the SPDX file is just one output, and we also use different outputs from the OSS Review toolkit that already contain that data.
Ah, very interesting.
So
thank you.
The SPDX file contains a subset of all the data that, for example, the web report from ORD provides. If I open that again, that report already contains a lot more information, and that's probably more information than is encoded in the SPDX file.
Right. Thank you very much. Right. Thank you very much for your answer. That clears things up a bit.
And
Fair
we
enough.
also have Sebastian Schubert here in the call at least, and he could correct me if I would say something that is wrong.
So in that case, is the dependency information you're showing coming from SPDX and other ORT reports, or is it just from other ORT reports that are more comprehensive?
I think in that case right now, the generated SPDX report is less comprehensive than the ORT report itself. So the both reports are generated at the same time by ORT. So the SPDX and this web app, and the SPDX does not encode the dependency tree right now. I think that's a feature request that is open and that might wait for SPDX 3, if I remember correctly, to be implemented. But the information is there, it's just not yet encoded in the report.
Okay, so in your demonstration here, are you from organization 1 to organization 2, are you passing on all the ORT output, or are you passing on just the SPDX output?
In that example, I would just pass on the SPDX output that describes the bill of material as a flat list, but it could be improved if the feature would be implemented that it contains the tree instead of a flat list. If that feature just would be implemented, so it's a feature that is that's missing here.
Sure, I'm just wanting to understand what parts of the demonstration are related to the capabilities of ORT and what are related to capabilities of SPDX itself.
Yeah. In this example, I'm just passing around SPDX. And,
okay, thanks.
Yeah, and the tools are exchangeable, so you could use other tools instead, generate SPDX and pass them around.
Okay, thank you.
Other questions?
To elaborate on the dependency tree SPDX problem, wouldn't it be possible to fix that with the current state by just having an SPDX document per package and then describe the dependency relationships within each package to reference an external SPDX document of the dependency package and create a tree of those? So not a tree in one document, but as we saw in one of your previous examples where you had a document where you had the dependency lists, and as somebody mentioned before that they saw that it looked like there was a dependency that was there was a dependency declared to the root package, and then they thought they saw a dependency declared as the dependency of that dependency. Wouldn't that still be the case, and you just have an external SPDX document defining?
Could use that, but why not just encode it in the file itself? So
I mean, one thing I can think of is that then you could just reuse that SPDX file of that dependency individually, and you don't need to regenerate the document. You can just refer it in the future. How many times would you? Depends on how often you use that package in other packages or in other scans.
Yeah, it would split it up in reusable components.
Yeah.
But there's also there's a discussion in the SPDX dev group whether that should be
okay.
I'm going off.
Okay, so the classic monolith versus modular discussion.
And if you should be allowed to split up or to copy elements. But yeah, you could just encode it here by saying that's a dependency of SPDX package X instead of the root package. So you could just encode the dependency tree here with these relations.
Okay. And in that case, would the opossum be able to parse that as well?
Yeah.
Okay, cool. Thank you.
So if I get a dependency tree, if I just convert the turn file, I think that contains tree of dependencies or longer hierarchies. Oh no, that's an old release that still contains a bug in the SBX output. Sorry for that. I cannot just convert that. Okay. After that, Chaos. Other questions? Otherwise, I would continue on describing what, for me, the goal of this example would be. I would try to enrich that and would make it more complete and make it even more complex, add more examples how to generate reports and how to pass them on, how to merge them to this supply chain, make it bigger, add more organizations, and that will hopefully help to understand and to prototype or to debug this supply chain. So that's the goal of this small project.
It's a very big, small project. I've got a quick question related to this case study. So obviously, we're beginning to cover a very large amount of ground with the case study, and this might be the biggest discussion yet. Do you think we should do a round table with some of the leads of the projects and maybe, also have input from them at some point in the future, an interactive panel or something like that?
Yeah, sure. That sounds like a interesting session.
Yeah, I think this was a really great demonstration. I hope we might be able to get some help with subtitles in a few different languages to help share it across the supply chain as well.
Yeah. I hope my chaos that I produced is subtitle.
That was far from chaos. That was great. I just want to check if our colleagues from China and Japan have any questions at this time. Okay, it looks like no questions at this moment. Max, that was brilliant. Everyone, thank you for the great questions. It looks like we have a lot more to do. There was a question in the chat about when or will a recording be made available? Yes, of course. A recording will be made available shortly. We always put them on our website. My goal will actually be to have this recording available within the next 2 hours or so. And with that, I just want everyone to take a moment for a big thanks to Max for pulling together the first time ever we've seen a virtual supply chain analysis for software bill of materials using open source tools and automation. That was fantastic. Thank you very much. And as you said, to be continued. So, looking forward to the next stage in this. Have a lovely day, everyone. Be well, take care, stay healthy, and we will be continuing our case study, as well as spreading this particular recording and our previous 4 recordings further and further across the supply chain to help ensure that every company of every size has access to automation and access to understanding how to optimize the automation. Take care, be well, and goodbye.
Goodbye.